Recently, I had a 20-minute DNS outage at one of the sites that I managed the network for, and while it was not a big deal, it was way out of working hours, it still really bothered me, and I realized at that moment that that site is not set up in the way that I typically set things up. So in this video, I'm going to walk you through how I typically set up DNS, why I like it, why I think it's one of the better ways to do it, and I'm going to show you kind of the security implications and benefits of setting it up in the way that I am. So without further ado, let's talk about DNS. Before this video begins, I do want to quickly mention that I'm now offering IT and network consulting. I do a lot with Ubiquity, FreeRadius, Proxmox, anything you can think of. It's all on my website, so go check it out, and I look forward to working with you. So at the base level, as we all know, DNS is essentially like the phone book of the internet. That's pretty much what a textbook answer will tell you. But essentially, it's converting a website, domain, URL, whatever, to an IP address that your computer can access. And that's basically one of the most important aspects these days to internet, because if DNS is not working, then a lot of sites are not going to load. Probably most things will not work, and you'll get unhappy users. So there's a lot of ways you can implement DNS in a way that increases availability, reliability, and redundancy. And there's a lot of ways that you can do it to reduce that as well. So first of all, let's talk about the most basic setup of DNS. So your computer, we'll say, can make a query, and this can just go straight to your ISP. So most ISPs have public-facing DNS servers, or at least DNS servers that you can access, and your computer will just make a query to them. Now, this typically works, and it's probably one of the better solutions. But what do we get from this on a security level? Well, first of all, your ISP can see your queries. Maybe if they want to change them, they could change your query responses. And essentially what that would mean is, let's say you wanted to access Costco.com. Oh, just kidding. You're actually going to access something else entirely. That's a bad example, but there are some websites that would be annoying to not be able to access the real version of. They could also block or filter websites. And there's a whole list of things like that. So it's essentially giving the control to your ISP. And now a lot of people may trust their ISP. I, in fact, do. I don't use my ISP's DNS servers for this very reason. If you are in the Midwest America, there's an ISP, Comcast, Xfinity, whatever, and they actually do this terribly. So they will actually hijack your DNS. They will block websites that they don't think you should be accessing. And there's a lot of filtering there that kind of annoys me. And this is where we get to our next thing. We have non-self-hosted DNS, but we also do have DNS solutions that we can host ourselves. So there are solutions like Bind, there's solutions like Pi-hole, there's also like AdGuard, I think. I don't know. Anyways, there's a ton of DNS solutions that you can locally host. And these are better because these take the control from your ISP and they move it down to you locally. So you're able to do what they call custom DNS, where essentially you can map manually basically a DNS record between your domain.com and your IP address. So essentially you have the control over where it's routed to. And this does, you still need to have an upstream DNS server, and a lot of people will still use their ISP. They might still use something like Cloudflare, Google, Quad9. There's a lot of public DNS servers that are available, but essentially though, locally hosting your DNS is a really good solution, because not only can you do private DNS records, you can cache it, you can improve the speed of your DNS queries, make websites seem like they're loading faster just because they're cached locally on a DNS level. But there's a lot of other things like that. It is a really beneficial thing to have a local DNS server. Now, going back to my Comcast example, I made a video, I think a while back, probably about a year ago, essentially though, talking about how Comcast does hijack your outbound DNS. How do we prevent this? Well, essentially, the DNS query that we were just talking about between your computer and Cloudflare is something called an unencrypted DNS. Now, this is pretty standard. It's how DNS mostly works, especially on your local network. Your computer contacting your local DNS server is going to be unencrypted, but they do have something called DNS over HTTPS. Now, this is a pretty modern solution that offers encrypted DNS. It's a lot hard to use it on a client-by-client basis, but if you have a local DNS server that is going up to the cloud, you can actually use DNS over HTTPS to combat something like Comcast hijacking your queries. And like I said, I've made a video about this in the past, but this is just a really cool solution in my mind on how to actually just prevent all of the unwanted filtering from happening. It's encrypted through HTTPS, which means, first of all, your ISP cannot see your queries. They cannot hijack your queries, and it's just bypassing them entirely, which you may wonder, like, is this even legal? Yes, it's legal. It is just a standard protocol, essentially. If they wanted to block it, they could block the URL that you're using to access, but I don't see why they would. That would basically impinge on your privacy. So I think at this point we kind of covered why it makes sense to have a local DNS server. It makes sense to use DNS over HTTPS to kind of connect your local DNS server up to something you trust. A really easy one is Cloudflare. That's what I use on all of my sites. Cloudflare is really nice. It offers filtering. You can do through their Zero Trust platform. You can filter out like adult websites. You can filter out gambling, whatever category-based filtering you have for free. They log for like 24 hours now. So you can access, like, see what websites were blocked in the past 24 hours. All kinds of things Cloudflare does. Really, really cool platform. Now, at this point though, how do we kind of fix this to improve redundancy? Because just having a single DNS server locally is probably not the most viable option. Even if you are a small business, even if you're a home user, you may want 2, 3, 4, 5. I don't know. So let me talk about my setup here. Actually, let's talk about my setup at the data center. So I have 2 VMs. I have a DNS VM, DNS 01, and I have DNS 02. So these are both virtual machines. These are both hosted on the same cluster. So obviously, in terms of redundancy, that's not the best idea. But essentially, though, these are their own separate entities. They connect to Cloudflare on their own. They have their own Pi-hole instance running on them. But what they do share is a common IP. But what they do share is the same network. So these are connected to the same network switch. You can see here with the blue, we'll make a little switch right here. These are both connected basically to the same network switch. And now technically this is a separate connection. I should display this a little better. So essentially, this is what it looks like. They're both connected by themselves to the network. And that's a really nice way to do it. So what that would mean though is on a client-by-client basis, you'd have to have, on a client-by-client basis, so you'd have to have a primary and a secondary DNS server of these 2 URLs. And you can push this out through DHCP, you can push it out through whatever. But essentially though, you'd have to have both these mapped, and it would primarily use this top one here. But then if the top one does go down, it would go and try a query again on the second one. Now, where this will get you is if you're blocking something through Pi-hole, it'll say like cannot resolve domain, or it'll return like a blank string or whatever. Sometimes computers will try the next one. So you'll see like multiple queries, and that's fine, but that's just something to note. And then one thing to mention is the setup I just showed you is exactly how I have it set up at the site that I had the 20-minute outage on, because I was working on the primary DNS server, but I actually never pushed out the secondary one through DHCP, which means nobody was using the second DNS server. And that was obviously a mistake on my part. I don't know why I didn't remember that, but primary one went down, not figure out why queries were failing. I was like, I have a secondary one. Nothing was actually using it. Oops. I know that's a lot to cover, but I think it's an interesting topic. It's all about where you put your, first of all, where you put your trust, where you put your reliability, your redundancy, and it goes back to what do you want to manage? Like, do you want to set something like this up, or do you want just a simple public-facing DNS server? Like I said, Cloudflare offers one, Google offers one, Quad9 has one. There's all kinds of open DNS ones you can use with different types of filtering on them, all kinds of things you can use. But what do you want to put your trust, reliability, and security into? Just an interesting topic. Let me know what you think in the comments down below.